Hey guys, welcome to the last section of Unit 2. Today we are talking about Section 5, which is on theorems about perpendicular lines. And remember that perpendicular is when two lines that intersect to form a right angle. So we have 5 different theorems we're going to talk about. You should write this at the top because your homework for this video is based off of the fact that you're watching this video. You're going to submit your notes at the end. So go ahead and write Unit 2, Section 5 at the top. That will be your first part that you need to write down, and then just follow the work that I do at the same time and just jot down any notes that I would make, and you will get full credit for this lesson. So the first part, number 1, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So here's our visual representation. Basically what that's saying is 1 and 2 are the same angle. So if we call them both x and x, they're a linear pair. Linear means line, pair means 2. So it's 2 angles that add up to make a straight line, which is 180 degrees. So if we take x and x, together they add up to make 180. So we get 2x equals 180. Divide by 2. The only value that makes sense for both of those is 90 degrees. So basically it's saying that those 2 angles, 1 and 2, have to be equal to 90. That's the only situation that would work there. Typically, linear pairs are not congruent to each other, but this is a perpendicular line theorem. Number 2, if 2 lines are perpendicular, then they intersect to form 4 right angles. So off to the side here, I'm just going to draw this. So imagine that we got 2 lines here, and they intersect. We know that they form at least one right angle, because it tells us that they're perpendicular. So that's 90. Well, if we know that angle is 90, we know that the vertical angle across from it has to be 90 as well, because that's the definition of vertical angles. So there's 2 90-degree angles. And then, based off of the theorem we had up here, since this right here would form a linear pair, and one of these angles is 90, the only other angle that would work for both here and right here is 90 and 90. So it forces all 4 of those angles to be 90 degrees, which is pretty self-explanatory. Justification, vertical angles, linear pairs, just like what I was showing up there. Now we're on to number 3. If 2 sides of 2 adjacent acute angles, remember acute is less than 90, and adjacent means side by side, are perpendicular, then the angles are complementary. So if AB, and this should say like D. So if ABD, which is angle 1, and CBD, which is angle 2, are perpendicular to each other, forming that right angle, that means they're complementary, which means they add up to 90 degrees. That one's pretty self-explanatory, because if they're perpendicular, they have to meet at a 90-degree angle, and complementary just means they add up to 90. So not much to justify there. Number 4, if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. So this goes back to corresponding angles. We know H and K are parallel to each other, and we know that corresponding angles have to be congruent if they're parallel. So if this one's 90, this angle right here would also have to be 90 since they're parallel. So that goes back to the corresponding angles postulate. Now the last one, number 5, in a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. This is probably the most important theorem because this proves parallel lines. So if we know that M and N are both perpendicular to P, the only way for those to be parallel to each other, or to intersect at a right angle, is if they're parallel to each other. And that's the converse theorem that we talked about. So if these are congruent to each other, 90 and 90, the lines have to be parallel. Okay, so that is it for the notes. Just make sure you have these little diagrams and stuff that I jotted down, and we will just do some practice with these problems the next time I see you. So